All right. Well, welcome back, everyone. We're going to now kick off the afternoon here and get this underway. So I believe everybody's back online, and if there's any questions or anything that's not working, do let Cheryl or I know. We're going to start the afternoon with a presentation from Mark Fletcher of Avaya on sort of the NG911 call handling use. And so, is the bridge back on?
Yes. Yes, it is.
Perfect. Welcome. All right, we're gonna get this thing rolling here now. So we're gonna turn this over to Mark Fletcher, and I think Cheryl's running the slides. Let's all yours.
Good afternoon, everyone. I'm Mark Fletcher, a product manager for Public Safety Solutions at Avaya, and today I'm going to introduce you to the concept of persistent, contextual, collaborative conferencing that can play a key role in managing the true multimedia communications in public safety. Cheryl threw out a lot of abbreviations before, so I had to make sure I had mine on the list. My goal today is to inspire your thoughts and ideas, and I'll keep my presentation short to allow time for an extended discussion. But as we move forward to make the recommendations about technical feasibility, I worry that a failure by the community to consider a market feasibility might reduce a likelihood of an acceptable solution being implemented. We all know PSAPs have their funding stretched very, very thin, and there's nothing in the law that mandates PSAPs purchase anything beyond what they have today. PSAPs, the technology that we're going to talk about today, is very attractive in the non-PSAP environment, and therefore it's got a good example or a good opportunity of being built. So, and that's going to be the conference bridge mechanism. So public safety, as we all know, faces a lot of challenges today. PSAPs are tasked with answering calls to public safety, but more and more people want to call emergency services less and less. The public wants to collaborate with public safety. And by that I mean communication sessions are becoming more commonplace, and public safety needs to look beyond a standard voice-only architecture to provide access to multimedia, multi-channel communications. That includes video, text messaging, pictures, social media. The general public has become immersed in the internet for more than a quarter of a century. Technologies such as vehicle telematics, smartphones are now commonplace in our lives every day. But public safety has been challenged with keeping up with that technology. For the most part, the infrastructure has remained relatively stagnant since 1968, yet the rest of the world has experienced the birth of the internet, advanced mobility, wireless, the IT bubble and its bursting. For many of us, work has become something that we do and not some place that we go. We use technology to share data and information with our friends, our colleagues. But again, public safety has been relegated to the architecture designed in 1968, which has had one major uplift in the early 80s of caller ID. For many agencies, words like collaboration, multimodal, unified communications are as foreign to them as the technology we see in the modern sci-fi movies. And I'm reminded of the story that Sherry Farina shared with us a couple of sessions ago about her husband who was bleeding profusely, and she was unable to make a 911 call to retrieve assistance. And it was only because of policy to respond to an unknown call or a call hang-up, did she even get any help whatsoever? That's just an atrocity that can't be allowed to go on. September 11th, 2001, and its 10-year anniversary coming up this year, taught us all lessons in resiliency, redundancy, high availability. It was one of our nation's most darkest hours, and we all realized how fragile we all are, and things like dial tone mean when you can't use them. But our greatest challenge is not technology. It's funding. And the constant diversion of legitimate tax dollars collected for 911 that get rated for other directives has simply got to stop. As we move forward making recommendations, think about the technical feasibility of all this. This is something that we can do today. And the National Emergency Number Association, of which I'm very active with, categorizes it by saying, in the past 15 years, advances in modern communications technology have created the need for a more advanced system to access emergency care. And while the existing 911 system has been a success story for more than 30 years, it's been stretched to its limit as technology advances. So on the next slide, we talk about communications being critical, possibly the most critical piece of public safety response. Selecting the right technology for the future is also critical, and possibly the most critical aspect of the public safety network. Networks have to be deployed with overall guidance from standards bodies such as IETF, NENA, recommendations by the EAAC, but they have to remain flexible in their deployment, as localized policy really determines the most effective deployment topology. Whether it's a decentralized model, and this is common in Europe where there's a different number for fire, police, and medical, or a centralized model where we have a private service answer point taking calls for all three services. And then that interconnected model, which is what the next generation 911 network will be, an interconnected network of networks. On the next slide, we see the 911 routing model today, and it can be summarized as one that captures data, transfers a call, where it then has to recapture that same data at the next agency in what we call the chain of care. Callers come into a center, the databases are queried, and in many cases that caller is transferred to another service. Yet the data and intelligence that we've collected about that caller remains with the originating agency, only to be recollected repeatedly as we move through the network. Now, in addition to this being an extremely inefficient method of providing service, historical archives, such as recording of the event, become difficult, almost impossible to track, as small pieces of the information become scattered about the entire network. And assembling that data after the event can become challenging and extremely resource intensive. Also, with this architecture, from a technology perspective, the functional elements, the pieces of gear that perform the specific tasks, have to be replicated at each point in the network. This increases capital costs as well as the overall maintenance and expenses. Now, although it's rare to refer to this model as simple, in fact, it is its simplicity that's let it exist for over 50 years. But new technology has become commonplace with the citizens, including the disabled community, and everyone should expect and everyone certainly deserves a robust and efficient solution, and that solution is Next Generation 911. On this slide, we show the new 911 network, the new Next Generation 911 network. And we now have the opportunity to introduce a new and innovative idea in the network to deal with the increased media payload: video, voice, text, email. Instead of taking that 911 caller and transferring them from point to point to point throughout the network, we take that caller and all of the contextual information that surrounds that caller, whether it be location information, geospatial information, caller context, and we anchor that in a multimedia collaborative conference bridge. People are attending this session on a multimedia conference bridge. We didn't have to email the presentation to 50 people. They came to the bridge, and everyone that's a part of that has access to that data. In the same way, when we anchor the caller and all of their information in this centralized multimedia bridge, any other resource that we need, such as language translation, relay services, interpreters, poison control, any other resource you possibly could need, can be brought into that collaborative conference. And not only do they have access to the caller, but all of the contextual data that's been collected during the call. Instant messages that have come in, emails, video. The Next Gen 911 network can transmit all kinds of relevant multimedia data. And now anyone becoming part of that session now has access to all of that information. And we do this using standard SIP technology. That's what SIP does best. It's multimedia, multimodal. The other part that is most important here is the recording. Because every piece of information and every person involved with this event is located in a centralized collaborative conference bridge. I have one spot to record. I have one spot to collect the information, and I've got every piece of information available without searching all over the network for it. So to better help you understand the value of persistent contextual collaborative conferencing, I call it PC3 for short, I put together a couple of use cases. So we'll go to the next slide. This is a vehicle involved in a motor vehicle accident. Automatic crash notification has alerted a service such as OnStar with the telematics information about the vehicle, the velocity of impact, how many occupants were in the car, where they were seated. All of this data is available. Computer models exist that can predict with, I believe, 90% reliability what the anticipated injuries will be from that accident. The provider will establish a collaborative conference with public safety based on the location of the vehicle. That crash data can be analyzed by components in the network, and while public safety is responding, the healthcare system, the hospital, which is also on that ESI network, the Emergency Services IP network, can start assembling trauma resources that are going to be potentially required. I didn't have time to look up this statistic, but I'm sure it exists. But I know by personal experience that when someone has a horrible accident, it would take probably 20 to 30 minutes to extricate a person from that vehicle, on average. I would say that's and if someone has another figure, please correct me. In that time, knowing what the injuries were in that accident, by the time the person is being taken out of the vehicle, the helicopter could be landing, and then you've got a 5 or 10 minute flight where the operating room, the trauma surgeons already have all the data that they need. And now we're not talking about saving minutes, we're talking about saving 15, 20 minutes or a half hour. And that has got to have an impact on how many lives are saved. The next example is with what I call the enterprise network. Businesses with PBX telephone systems. Enterprises have a ton of information about their users on the network, and when those users make a 911 call from a building, public safety is challenged to find out where they are in the building today. But now, with Next Generation 911, that 911 call can leave on a SIP trunk from the enterprise, and information such as, oh, Mark Fletcher just dialed 911, yeah, that's important. But other information such as IP-enabled temperature sensors in a building that are all reading 200 degrees. Well, that probably indicates a fire. So again, having this data allows public safety to target a more zoned-in response. In addition to that, information such as building floor plans could be transmitted to public safety and in turn forwarded to the first responders. So now with devices such as tablets becoming more and more prevalent, the emergency medical technicians or firefighters walk into a building with a tablet in their hand with the floor plans of exactly where the 911 caller is or where the emergency is. And on that floor plan are all the fire extinguishers, the egress and ingress points, and emergency exits. Valuable information that can shave seconds, minutes off of emergency response. The next use case applies to this particular community of folks. And thank you for Al in correcting me. I had this labeled as a with a VRS instead of VRI, and today I learned the difference between the two. And this is actually VRI. But an ASL caller makes a video call to 911, not to a relay service. They call 911 just like every other citizen can in this country. And then on the Next Gen 911 network, that video call enters into the PSAP in a video conference. And because it's a video conference, a VRI service from another center, from an external company, anybody that's on that emergency services IP network can now be brought into the conference to perform video translation with the call taker online. And again, centralized recording can capture all of that media. We had a discussion of which pieces do I need to record. In this case, we can record all pieces. The caller, the person performing the interpretation. And in the last example is a regular voice caller coming into 911. And because they're using a smart device, or they're coming off of a enterprise network that has intelligence? Cheryl asked this question last week. How do I know that that caller has a special need, such as language? That can be provided as a language indicator. So when the call comes in, the ESI network, the system knows that I need language translation, and preferably which language I need. So again, that translator, whether they're on the network, at another agency, or in a contracted company that has network connectivity, is brought into that conference, immediately providing translation services. And again, centralized recording takes care of all sides of this. So on the next slide, Avaya has been a provider of contact center applications for several years. We understand technology requirements required to connect people with needs to people who can provide assistance. And that is the same whether you're calling to buy a part for your lawnmower, the latest sweater in my fall catalog, or you're calling for emergency services. When you call any major corporation and you have a service call into them, and they say, yes, Mr. Fletcher, we'll have the service technician out to you at 2 o'clock this afternoon. They know this because they know who I am. They know what my needs are. Using this same information, we can identify people and their needs on a next generation 911 network, not just by a telephone number, which is becoming less relevant to location as we expand our level of mobility. And public safety can provide the resources that we need to service people and get them the assistance that they need. So lastly, Avaya and our business partners are dedicated to providing solutions that improves public safety response. I want to thank the committee members for allowing me to present our vision of persistent collaborative conferencing for public safety communications and the network of the future. And at this point, I'd like to take any questions or hear any input that you might have. Thank you.
Thank you. We have Bernard is online. Go ahead, Bernard.
Yeah, Mark, I think it's fair to say that a number of these concepts are incorporated into NENA I3 Stage 3 document, although it doesn't describe all the call flows you mentioned in your presentation. But I think that document is based on the concept of a bridging architecture, right?
Yeah, you're absolutely right, Bernie. The bridging architecture is noted in the NENA I3. And again, may not have all the individual call flows because the group really didn't focus on the specific use cases. But I think it's safe to say the spirit of that agreement would support any use case that could conceivably happen.
Yeah, so I think it's important to emphasize this isn't just a proposal, it actually is the substance of the next generation 911 recommendation.
Absolutely. You're absolutely correct. Thank you.
Greg Vanderheiden.
Yeah, I think the analogy of the room, having everybody come into a room, is really powerful. When you talk about bridging technologies and things like this, most consumers, et cetera, have no idea what this means. But if you say, when you call 911, you and the 911 caller would be in a room. And now if they need an interpreter, they can invite them into the room. And everything that's being said is there. So if somebody else joins the room, another specialist, a language translator, anything else, all of what's been said is all written down on the wall, and they can immediately come in, join, and people get the idea that they're all in this together instead of talking about, having people and bridging and bringing in an interpreter, and as soon as they hear the word relay, they get this idea of somebody being between them and the other end. So I think that the analogy is very good, and I think that the model is really excellent too, from the standpoint of consumers and being able to bring in resources as they're needed. So I just want to speak strongly about this, and I think we should be thinking about this kind of approach, generically. Now, people have talked about this in the past, but sometimes they've talked about it in technical ways that most of the people, the consumer end of it, can't understand what the implications are or what's being said. Also, I think the thinking has evolved a lot, and we've gone from bridging networks and things in the past to having technologies now that allow us to approach this in a very different fundamental way. And it would be interesting to hear how close or how far we are to being able to actually implement this kind of a thing with phone and internet and other systems. Thank you.
Thanks very much for that, Greg. You're absolutely right. And we have, this technology is in use today. This is not something that's on the drawing board. It's not something that's prototyped. It's something that exists today. And this is a model that businesses would use as well. It probably is going to emulate from just the general video conferencing capability. And then we add in the new devices, and with the tablet devices. And the recording piece of this. This is all technology that exists today. And it's really using those pieces of technology to fix a problem that has existed. And, let's face it, 911's been around since '68. They added caller ID and nothing more. Good golly, Location. Location is probably the most important thing about a 911 call. If they don't know where you are, how are they even to... Forget about routing you. How are they going to help you? It doesn't matter who answers your call. Get the responders to where you are. We can fix the routing problem, right? Devices are intelligent today. Networks are intelligent today. There's a lot of data that can be offered to the public safety network that they can use to, collaborate and route people responding and, poison control, things like that. So this is not a hard problem to solve.
One more person in you. Okay. Well, Donna?
Yeah, hi. This is Donna. Donna speaking right now. The information looks good. The presentation was great. I just wanted to make a comment about the database. I just wanted to let you know that NANA, they have a work group called the Next Generation 911 add-on total. And that work group they take notes that cover the three areas: the caller, the caller location, and they talk about what's involved in each of the databases, and the 911 technology can be involved in different databases. You've got the caller here, and if they want to set up, you want to have you want to set the field, the same field, but the caller, let's say, is a volunteer, okay, and they could maybe fill out some kind of comments about themselves, for help, like. So that way that information could already be in the database, and that way that would provide quicker service for the interpreter, would have that information. If they have problems with their heart, or for one thing, or, you know, I mean, it could be voluntary only, not required. You know, they could fill this out, you know, so when they're, you know, calling or whatever, whoever through the system, and they connect to the 911 people and the interpreter and all of that. Like, for example, you know, for the NINA network group, I think, you know, I think that would be something that they could work on, something like that. You know, Delaney Arnold, I think she's the manager of that data technology base. And so I don't know. We could, you know, we could get her involved and that company involved too to help with that. I just wanted to throw that out there as a comment.
Yeah, no, absolutely. There are several initiatives that exist.
Oh, you know what? No, wait a minute. Hold on one second here. Let me say this again here. Let me go back here.
This is Cheryl King. Donna, while you're preparing your next comment, I would like to just clarify that was a great presentation, Mark. Thank you very much. And that is an Avaya business model, business product?
Yes, it is.
Okay.
It's a concept that we've developed using our multimedia technology, yes.
Right, okay.
But it's a common model in the industry.
Right, that's what I was getting at, that there are other models, other business products that are similar, and so, you know, if we as a committee, you know, look at that structure, and that structure is what we recommend, what we see as encompassing all of our understandings and expectations of the next generation 911, then that would probably be a good stepping point for shooting off into the working groups for the recommendations. Can I have some discussion about that? And I think Bob had his hand up. Bob Mather. Go ahead, Bob. Or Donna, you let us know when you're ready.
Hi, this is Bob Mather. And your presentation was very exciting. It was great. I think for providing access to all. One of the issues that I'd like to address is SIP. Is that the standard for interoperability with MMC, or MMC is conferencing capability?
Multimedia conferencing, yes.
Multimedia conferencing, right.
Smart Fletcher, yes. SIP is the standard architecture for performing that type of function of the network. It's what the NINA i3 model is based on. SIP is Session Initiation Protocol. It's two endpoints talking to each other and establishing a session, and then any type of media, voice, video, pictures, text, being added on top of that, and that's why SIP is used for that type of session, yes.
I have Sherry. We still have to go back to Donna, right? But Sherry, and then I do have Paul and Bernard online as well. Go ahead, Sherry.
Are we still waiting for Donna? Okay.
She'll let us know when she's ready.
Yes,
Sharon.
just go ahead.
Okay.
Oh, you know what?
Mark,
Just
wow.
You know what? Sorry,
This is...
You know what? We'll just go ahead, okay? I just withdraw my hand, okay?
Okay.
All right, Donna, thank you. This is Sherry speaking. Thank you, Donna. Wow, Mark, thank you very much, because that was very exciting to see your the concepts that you presented, and also to know that there are other people in the industry who have been thinking, who have been having the same kinds of ideas, the same kinds of setup, as well as Nina. That was very helpful to know. And I'm excited to know that Bob is excited. That's important for me, because he's the DOJ guy. So let's hear it. I had a question, which I've forgotten, but I think, in my opinion, the concept, as you presented it, that centralized network, that concept, to me, that takes care of any future technology development. Today we're talking about the different kinds of devices that you all play with, your toys that you play with, but in years to come the toys are going to look different and telecommunication is going to look different. So to me it makes sense to have this centralized bridging to take care of whatever, no matter what the telecommunication toys are, that model would still provide access, and that's the key. So if everyone agrees to that concept, then we can all go fishing. I don't know if there's any competing business involved with this kind of concept, but to me, the concept itself, as you presented in your presentation, allows for access and ongoing access without having to stop and reinvent the wheel. And I think that's one thing that we've been afraid of, having to develop recommendations and making recommendations that we want to be able to develop a recommendation that could go forth. So thank you.
Thanks very much, Sherry. And I have to say, your story is really inspires me to tell this story, because when I look at what you went through, and trying to make a 911 call, getting to the 911 center, but being unable to speak or communicate with them, you know, it certainly drives me personally, and I think stories like that should drive the industry. So thank you for being an inspiration.
Thank you. Well, I have Paul Michaelis and then Bernard. And Peter?
Okay, this is Paul Michaelis with Avaya. A point that was made earlier that I'd like to reemphasize is that the architecture described by Mark is quite consistent with what our non-PSAP contact center customers are looking for. Going forward, as we start generating recommendations, the extent to which we can come up with recommendations that are not PSAP-centric, but might also be of value to our non-PSAP contact center customers, those are the ones that are going to get built. By contrast, any recommendations that are entirely PSAP-centric, keeping in mind the funding model for PSAPs, those are less likely to get built. And so, again, moving forward, the extent to which we can leverage technologies that our other customers want, such as the collaborative conferencing designed by Mark, or described by Mark, is really the way we ought to be going. That's it for me.
Okay.
Thank you, Paul.
Thank you, Paul. Bernard and then Peter.
Yeah, I just wanted to address the issue of deployment in existing situations. The voice architecture that Mark described is, of course, very widely deployed. I mean, we're using it right now. We're using a conference bridge. That's essentially what we're talking about. So that's extremely widely deployed and highly interoperable. When you move to video, there is more controversy there and more issues in interoperability. In particular, right now, when you're looking at a video conference, there is differences among the codecs that should be used. For example, a lot of people think that scalable video FCC is important because it allows the different members of the video conference to potentially see the conference at different resolutions and so forth. But it's likely that that will be solved, down the road. And in fact, if you look at NENA i3 Stage 3, it does make some recommendations with respect to video within this architecture. I think the place where it's a little, using SIP, both for audio and video, the place where it gets a little stickier is for text. And that is because, in my experience at least, SIP as a multi-user conference mechanism has not caught on, and it has been eclipsed by a different technology, which is XMPP. And so what we're seeing in XMPP, in fact, multi-user chat is the standard adopted by the Department of Defense within the U.S. government. So at least what we're seeing is kind of a divergence there on the text versus the audio video front. And in particular, in the MUC area, We've recently seen the development of real-time text solutions which are based on XMPP, so that you can have this kind of conference framework within a real-time text functionality.
Okay, thank you, Bernard. I never, and now Peter.
Okay. Peter Musgrove. See if this is working out. There it goes. I'm Peter Musgrove from AT&T. I'd like to thank Mark for the presentation, and I know that you can break the architecture that Mark showed up into different pieces, like the PSAP side, the ESI net, both of which you talked about some. There's also the origination network piece, whether it's mobile networks, wireline, cable, whatever. In the standards arena, 3GPP has worked on something called the IMS emergency calling, and that provides basically the access piece. In ADIS, we're working a North American variant of that to make sure that any North American specifics are taken care of. In ADIS, we call it the IMS ESI net project. IMS is the IP multimedia subsystem. The point is that the acronyms are not important, but what's important to know is that that's basically the method used by mobile or wireline networks or any network that uses SIP to set up voice over IP calls via the IMS and via the 3GPP standards. So ADIS is working a project on this already. I think the option that Mark talked about is a very good candidate to throw into this technology group that Don and Susan talked about earlier, the one that will review the candidate list of solutions.
Christian? Hello, this is Christian. And I have a comment. Wait a minute. Okay. I have a comment related to the SIP, because we are excited about the issues related to video. And now that there are some VRS users who are using SIP and others do not. And our experience is that SIP is a wonderful start. It's a wonderful step for interaction. But without the video component, the devices need to come together in codec. And that's one of the issues. For example, a VRS provider may provide SIP, but a manufacturer may also provide it, may support SIP, but the two are not able to connect. So sometimes it works and sometimes it doesn't. So it doesn't have that functionality. So obviously there's a lot of work that has to be done. And I've not had the time to read the I3 recommendation, the report. So I don't know all that is contained in the report. So the question I have is, if we were to provide, and if we were to go ahead and use SIP, how would you make sure that the ideas of the using SIP, how would you make sure that it's interoperable and everyone is able to talk to each other?
I don't know if Mark has a response. I know Dawn has a response. So Dawn, we'll go to you first.
Go ahead.
Respond to me and go ahead, because I have a different point.
Oh, okay.
Go ahead, Mark. Sorry.
So to respond to it's Mark Fletcher. To respond to that, SIP is the underlying transport architecture, and as you mentioned, the SIP implementations can be very, very different. And this is where the standards bodies are critical in defining, you will do this to support video over for 911. This is the requirement. And by making it a requirement, the manufacturers have to comply with it if they're going to have a product. I say we should come up and put an E911 or emergency services logo on a device. And if you meet the requirements of the commonly accepted technology, you get to put it's like the Energy Star logo on your refrigerator. We should have the emergency services star sticker on the device. And it's easy to define the standards, and once they're defined, it's easy for the manufacturers to build to that. I'm not talking about impossible technology. We just have to get the incentive there to build it.
I'm a manufacturer. I'm not sure about stickers on everything, but a lot of things. We're going to go to Dawn. I know Bernard had raised his hand, so I don't know if he had to respond. Go ahead, Dawn, and then we'll go Bernard and then Joel.
Hi, Don Mitchell, TCS. I wanted to highlight what both Mark and wow, name just completely escaped me. Oh, Paul said about the public safety side of this equation. It is in deploying 911 systems, the funding issue is a rather large issue. Actually, is probably the large issue. But I don't think in this EAAC committee that we can punt on that issue and not address it. I think that it is something that in our policy group we do need to discuss that because it is a reality, and if we ignore it, we're not going to really fulfill our charter. We may not be able to change states because we don't have authority over that, but we can certainly give recommendations to the FCC on actions that they may be able to influence in the future. I believe that that's a relevant thing for us to do, so I just wanted to bring that out.
That's a good point. That's a good point, Don. Thank you. Bernard, and then Joel.
Yeah, I just wanted to address the interoperability issue that was brought up. And I agree that the standards bodies are needed there. To be clear about where we are at the moment, NENA I3 Stage 3 does provide detailed call flows for many of the voice scenarios and some general recommendations on some other scenarios, including text and video, but it doesn't get into perhaps some of the detail that you would need to solve the video in more detail. So you'd probably have to have another effort that would go into more detail on those call flows so that you'd know exactly what to do. But I don't think we could solve all those problems in the EAAC. You kind of have to get the standards body going with a general direction and then ask them to fill in, the level of detail you need to get there.
Joel?
Yes, thank you. Joel Zepp. I'm sorry to keep beating on one point. I think Mark's presentation was excellent, but I'm really needing to keep our focus on those who do not have devices. I'm dealing with and have dealt with thousands of people who are poor, who live in inner city, who don't have all these pieces of equipment, who don't have devices, who don't use the computer, who really can't handle any of that. And we're doing away with fire pull boxes in the communities frequently. We really need to be thinking about also, among all these wonderful things that we're talking about that Mark was presenting, ways in which those who are not up to speed, either financially or intellectually, especially that we're moving more and more people or keeping more and more people in the community rather than nursing homes, rather than other kinds of facilities, we need to be thinking in terms of how can they access. One of the things that comes to mind is providing devices, if you will, that maintain a recorded burst of information that someone contacts 911, hits a button, gives their location verbally or whatever, gives some key issues of the home, and that's that information flow, either analog, verbal, or digital, into the PSAP center to handle it. But I want to make sure that because we're so comfortable with technology and with devices that we're not leaving out thinking about those who aren't able or will be up to that speed at this time or in the future. Thank you.
I have no one else on the hand raising, and I see no additional hands here. Okay. So, Mark Fletcher of Avaya, thank you very much for
Right on time,
the presentation. And yes, you're on time. Very good. Thank you.